我们是不是差不多可以开始了？ Hello. Hello, everyone. Hello. Hello, everyone. Can you hear me loud and clear? Well, if you can hear me, you can just type a 1 in the chat. Hello. Can you hear me? All good? So if you can hear me, you can just type a 1 in the chat to let me know. Yep, that's good. Thank you. No problem. So we will be starting at 7 p.m. sharp, all right? It's good to see you all again. And also, of course, congratulations on finishing GEPs. Well, if you are doing GEPs. So, how did you do in the round 2s? Well, I surely do hope that everyone's doing well in round 2. Hello. Oh yes, Tiger, yes. Fears, not so much. I would not describe myself as fierce. Is it hard? Like so hard? Really? Well, let's hope that the hard part is not about maths. So we'll start in 2 minutes, all right? And I hope that you have all done the paper already, such that we can just do a little bit of, walkthrough for the questions. And personally, I think this piece of past paper question is slightly easier than the sample paper we did last week. So if you find the sample paper all right, you should be fine with this one as well. The hard part is maths, really? Oh no. Well. And English. Woohoo. Good for you. All right. So we're about to get started. It's gonna be any time from now. Less than 1 minute. GA is easy. Okay. Well, then it means that at least you have done one paper well, which is good. All right. So you do agree that GA is easy. Okay. All right. Anyways, we are now getting started with the paper walkthrough. All right. Are you all ready? So let's talk about this paper. First of all, this is going to be 2023 TASMO paper walkthrough, which means that this is going to be what we are actually doing in the exam, like the TASMO exam last week. And now I'm just going to go through every single question in this paper. So, well, of course, that requires you to have a little bit of prior knowledge to most of the contents again. But personally, I think this is going to be slightly easier than the sample paper last week. So let's take a look at the first question. Here, we are trying to see which of the following would give a result of an even number. So this is, it is hiding a little bit from the screen. So let me just try to rearrange the size of it maybe. Okay, I think it's good now. So, which of the following will give a result of an even number? This is about parity. So first of all, we don't need to calculate it out, definitely. That would be too complex. What we need to do is to identify whether each number is going to be odd or even. That's all we need to do, all right? So for the brackets, even take away odd, that's just going to be an odd number times an odd number, adding an even number times an odd number. So that goes to an odd number adding an even number, which is going to be odd. Is that right? So the first one is not the answer. For the second one, we have an odd number times an odd number. That's odd. This is even. This is odd. This is even. This is odd. This is even. This is odd. This is even. And after you add all of these up, you will see that the answer is going to be an even number, because you have 4 odd numbers that is going to add up to an even number, and then adding more even numbers, that's still even, right? So this is going to be the answer, and let's take a look at the other 3. Well, since we're already here, the third one, we have odd times even, that's going to be even, and this is going to be odd. So even adding odd, that's odd. All right? And for D, we have the first section being all even numbers multiplying together, that's even, removing the second section, which is all odd numbers multiplying together, that's odd. So it means that the answer is still going to be odd. So this is wrong as well. And the last one, even times odd, that's even. Odd times odd, that's odd. Odd times even, that's even. And the last one is even. So we have even, adding odd, adding even, take away even. But there's one odd only, which means that the answer is still going to be odd. Is that right? So the answer is going to be B for this question. All good? That's the first one. Just a little bit of analysis, and if you're going top down, you can get the answer at the second option already. And for the next one, it's a little bit about an observation. Find the next fraction in the sequence below. So we have 1/3, 1/2, 5/9, 7/12, 3/5. Looks a little bit dodgy, right? They do not really go in a pattern. However, if you're identifying 3, 9, and 12 there for being multiples of 3, you can then realize that the second one and the fourth one are coming from some simplifications. So the second one should have denominator going to 6 if you follow the multiples of 3. And the fifth one is going to be having a denominator of 15 if you're following this pattern. So by expanding these fractions, you will get the numerators as 3 and 9 respectively. So now you can see that the denominators are going up by 3 every time. And as for the numerators, that's going to go to 1, 3, 5, 7, 9, so consecutive odd numbers, which means that the next denominator is 18 and the next numerator is 11. Okay, so that's how we can get the answer for the second question. Is that right? Now, let's take a look at the third one. So for the third one, again, we need a little bit of observation. So the star is an operator that acts on 2 numbers. By observing these numbers, you can see that the first digit or the first 2 digits, they come from these 2 numbers add together. The last digit it comes from the difference of these two numbers, right? And the same goes for the middle two, of course. So I'm not going to elaborate it. So we can see that 7 star 5, we have 7 adding 5 equals to 12. 7 take away 5 equals to 2. So it means that the answer is going to be 1 to 2. All right, the first 2 digits coming from 7 adding 5. And the last digit coming from 7 take away 5. Is that okay? So that is what we have for question 3. Why are you typing some gibberish in the comments? Okay, and for question 4, a series of colored lanterns are arranged in the following pattern: red, 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 green, yellow, yellow, yellow. Red, red, green, yellow, yellow, yellow. So you can see that the pattern is actually starting from the 3rd term or the 3rd lantern. And it is going by 6 in each group. All right? Now, if you have 50 red lanterns, how many yellow lanterns are there at least? So you can think about it. Before having the pattern going on, there are 2 red lanterns, and for every single repetition of the pattern, there will be 2 red lanterns starting in the pattern, right? So it means that if you want the least number of yellow lanterns, you can have red, red, and then repetitions, 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 going on until you start another new repetition with 2 reds, and that's where you can stop. So now, if there are 50 red lanterns altogether, removing the first 2 and removing the last 2, the number of red lanterns in the repetition is going to be 50 take away 4 divided by 2, because we know that each group has 2 red lanterns, right? So it means that it has undergone 46 divided by 2, that is 23 repetitions. And in each repetition, we know that there are 3 yellow lanterns, which means that the least number of yellow lanterns is going to be 23 repetitions times 3 yellow lanterns in each. That's going to be 69 altogether. Okay, so the answer is C. Are we all good? And then, moving on to the next question, we have sets A and B, as shown in the Venn diagram. And they have the same number of elements. Now, their union has 2007 elements, which means altogether, contained in these 2 bubbles, there are 2007 elements. And the intersection has 1001 elements. So, how many elements are there in bubble A? We know that in bubble A, it's going to have the same number of elements as in bubble B, right? And you can see that 1001 is actually counted in both bubble A and bubble B. But the union, 2007, is just counting it once. So in order to find the elements in either bubble A or bubble B, you just need to add an extra 1001 to 2007, and then divide it by 2. So now you will be able to get the answer, which is 3008 divided by 2, going to 1504. So the answer is C. Okay? This one, question 4. It's C. It's C. Because you don't really need 24 repetitions. You can just start the last repetition with 2 red and then just stop there. You don't need to carry on with the repetition, right? So it means that last 3 yellows does not really need to be there. Okay? So that's the reason why it's 69. All right. And for question number 6, it says that in a certain year, July has 4 Fridays and 5 Saturdays. So what day of the week is July 15th? So now, what we know is, for any month of July, there has to be a complete set of 4 weeks, which is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, repeating 1, 2, 3, 4 times, all right? So I'm just not going to write everything out, but it's just repeating 4 complete weeks. So in order to have an extra Saturday than Friday, it means that the first day of the month has to be a Saturday. And another extra day is going to be the Sunday. Another extra day is going to be the last day, which is a Monday. All right? So that's going to be how this July is going to look like. And what we can see from there is that because the 1st of July is a Saturday, which means that the 8th of July is also a Saturday, and the 15th of July is also a Saturday. So the answer is going to be C. All right? That's what we can say about this question 6. And then for question 7, a single tournament has 6 players. Each player has competed against every opponent only once, with no ties. So the total number of games is going to be 6 times 5, because we know that every single player has played 5 games, right? However, you need to divide that by 2. Because imagine if you have 2 candidates, say Alex and Bob, all right? So Alex playing with Bob is Bob playing with Alex. So every 2 players have actually just competed once. So you need to divide that by 2, and you can see that there's just going to be a total of 15 games altogether. Now it says that the first 5 players has won 4, 3, 2, 2, 2 games. So for the last player, Monica, she would have won 15, subtracting 4, subtracting 3, and subtracting 3 of 2s, which means 13 altogether. And Monica would have won 2 games, all right? So the answer is going to be 2. Is that okay? So that's what we have for question 7. Is it question 7? Yeah. So now we are at question 8. Jason is reading a storybook, and starting from the 2nd day, he reads 1 more page than the previous day. So it means that every day he's reading 1 more page. Now he has been reading continuously for 9 days, and there are still 48 pages left in the book. On the 4th day, he's read 39 pages, which means that on the 1st day, Jason would have read 39, take away 3, which is 36 pages. Because the 4th day is 3 days later, right, than the 1st day. So that's 3 more pages. And on the last day, which is the 9th day, Jason will have read 36 adding 8, which is 44 pages. So altogether, the total number of pages is going to be, just calculate the arithmetic sequence, first term adding last term, multiplying the number of terms, which is 9, divided by 2. And then an extra 48 pages on top of that. So now what we have is 80 times 9 divided by 2, which is 360, adding 48, which means that there's a total of 408 pages in the storybook. Is that right? So that's what we have for question 8. The next one is going to be question 9. So for a 6-digit number to be divisible by 25, we just need to know the divisibility of 25. Because we know that 4 times 25 is 100, right? Which means that everything that is in front of the hundreds place will be divisible by 25. So I just need to look at the last 2 digits to determine the divisibility of 25, which they might end with 00, 25, 50, or 75. So now there are 2 different possibilities that it might end with 5, so the number of different possible values is going to be 2. The box is either going to be 2 or 7. Is that right? So that's what we have for question 9. And now, we are at question 10. It tells us that an island is inhabited by 2 types of people, truth tellers or liars. The truth teller always speak the truth, and the liars always lie. There are 25 of them stood in a line. Each of them, except the first one, says that the person directly in front of me is a liar. And the person standing at the first one says, everyone standing behind me is a liar. So first of all, let's imagine if the first person is telling the truth. It means that everyone behind the first person, the next 24 of them, are all liars. Is that going to be possible? So think about it. If I have a liar in the line and another liar saying that the person in front is a liar, which means that that's actually telling the truth, right? The next one, following the previous guy, has to be telling the truth by saying that the one in front is a liar. And the next person accusing this truth teller to be a liar has to be a liar. And the next person has to be a truth teller, right? So on, so on. So it means that it's going to go alternatingly in liar, truth teller, liar, truth teller pattern. And as for the first one, of course, the first one must be a liar, right? Because definitely there are truth tellers standing behind him. So that's meaning that the first one is a liar. So if this pattern continues, you can see that we will have 12 groups of one liar and a truth teller. 12 groups. Until you get another liar and another truth teller. The last one would be a liar. So it means that there's going to be one more liar than truth teller in the 25. And there's going to be 13 liars in the line. Is that okay? Question 9. Okay. So this is what we have for question 9. The answer is B. Because for the divisibility of 25, you just need to look at the last 2 digits, all right? If the last 2 digits is divisible by 25, then the entire number is divisible by 25. So the only possibilities are going to be 25 and 75. Is that okay? Well, yeah, and it cannot be 1 as well, right? So that's the reason why it's D. So that's for question 10. And for question 11. So for this one, we just need to spot the pattern, okay? The figures are made up of many triangles. Every triangle needs 3 matches to form. So for level 1, it is just 3 matches, right? For level 2, it is actually just adding 2 more triangles on top of level 1, which means 6 more. For level 3, it is adding 3 more triangles than level 2, which means it is going to be 9 more matches. And of course, for level 4, it's going to be 4 extra triangles, and that's going to be 12 more matches than level 3. So you can see that these are all going up in multiples of 3s. And again, that's the sum of arithmetic sequences. So to form a level 40 triangle, it means that you're having the sum of 3, adding 6, adding 9, adding 12, all the way to 40 times 3, which is 120. So now that's going to be the first term adding the last term, multiplying the number of terms, which is 40, divided by 2. So that is 123 times 20, which is 2,460. Is that right? So that is for question, which question is it? 11. Are we all good? And question 12. Using the digits 0, 3, 5, 6, and 8, how many 4-digit even numbers without repeating digits can we form? So we know that in these numbers, 0 is a special one because 0 cannot be used as the thousands place or the starting digit of a number, right? Which means that now we can just classify this question into 2 possible cases. The first case is when the number ends with a 0. If the number ends with a 0, it means that you just need to choose the first 3 digits of it, and it can be any of these remaining digits. So we have 4 times 3 times 2, which is 24 cases for it to end with a 0. The second category of it is that it ends with either 6 or 8. So first of all, we know that there will be 2 different possibilities for the ones place, right? It can be either 6 or 8. And after choosing any one of them, next we are going to look at the thousands place. We know that 0 cannot be the thousands place, which means that in either case, I will just have 3 digits left for the thousands place. And after that, I have already chosen 2 digits. For the rest of them, they are free to go into any of these places. So 3 times 2. And 2 times 3 times 3 times 2 goes to 36 cases. All right, so that is going to be adding up to 24 adding 36, which is 60 different such numbers that we can form. Is that right? So that is for this question. The next question, question 13. A group of children divide a pile of apples. If one person was removed, each of them can get 8 apples. If 2 people were added, each of them can get 6 apples. So now it means that if you are giving everyone 8 apples, it's going to be 8 in short, right? And if you're giving everyone 6 apples, there's going to be 12 apples in extra. So it means that by giving 8 apples and 6 apples, the difference in the number of apples that we need is going to be 20. And 6 times 2, which is 12. Sorry about that. And that divided by the difference in the number of apples that everyone is getting, which is 8 take away 6. Now we will have 20 dividing 2, which means that there are going to be 10 children, all right? So this is one of the easiest models for the deficit problems, like, what is that called? Excess and deficit, all right? So that's what we have for question 13. And now for question 14. A group of children were discussing their pocket money and found that on average, each of them had $58. So now if they have an average of $60. And this new child has brought $70 altogether. Which means that this is 60 and this is going to be an extra 10. So where do these extra 10 go? Of course, it would go to these people, right? And for each of these people, we know that they need $2 more in order to reach the $60 average. So it means that the number of children originally is going to be 70 take away 60, that's the extra $10, divided by 60 take away 58, which is how much each of these original kids needs to get in extra to reach 60. And that's going to 10 divided by 2, which is 5. So the answer is going to be 5 for this question. Is that right? What page? So we are now at question number 14. Okay, this is question number 14. Are we all good? Okay, so for question number 15, let's take a look at this question. So now, first of all, you need to know that for any rectangle, if you're splitting it into 4 sections, let's say these lengths are going to be A, B, C, and D. We know that the area of the first section is AB, the second section is BC, the third section is CD, the last section is AD. So it means that if you are multiplying the areas of these 2 rectangles, it's going to go to ABCD, and that's going to be the same as if you're multiplying the areas of these 2 rectangles, which is also going to be having a product of ABCD, right? So now, with that in mind, you can just try to think about this question. You want to find the star, and you can start with this rectangle. So 2 times something is 8 times 6, right? So we just need to do 8 times 6 divided by 2. And that's going to be 24 right there. And then you can move on to this rectangle. You can see that 24 times 6 is going to be 8 times this something, right? Which means that this box is going to go to 18. Is that okay? Nah, it's just 1 hour. How do we expect a break in 1 hour? No, we don't have a break. Just carrying it on, finishing it once and for all. And for this last rectangle, you would have this. That's the answer. Oh, it's not actually on the book. I mean, I have sent the papers in the group chat. Maybe, I guess if you're in the live, you should be having the group chats, right? So we are sending the paper in the TASMO group chats. Okay, now for question number 16. We have some socks with different colors in a bag. A white one, 2 black ones, 4 red ones, 8 yellow ones, 9 blue ones, and 9 green ones. Cindy is now picking some socks from the bag without looking at them. In order to guarantee that Cindy is getting 5 socks of the same color, how many socks should she pick at least? So now, the keyword here is to guarantee, which means that we need to think about the most unlucky case, right? So the most unlucky case, of course, is to get all these socks, which can never reach 5, first of all, right? Because for white, black, and red, they will never get 5 socks. And for the remaining socks, the most unlucky case is to be getting 4 socks in each color, yellow, blue, and green. So that's the most unlucky case, and that's the maximum number of socks Cindy can get without having 5 of the same color. So as long as she is getting another 1 sock, it can only be socks which is either yellow, blue, or green. And that's reaching 5 for that color. Okay, so altogether, you will have 4 times 4, adding another 4, which is going to be 20 socks. Is that okay? So that's for question number 16. You don't have a group chat. Interesting. Well, you can just click on the, official account and send us a backstage message. Okay? And now, for question number 17, it tells us that there are 150 students in primary 3. When assigning them to different classes, the teacher finds that no matter how the students are distributed, there are always at least 22 students in one of these classes. So this is like a pigeonhole theorem. You can just try to think about what is the maximum number of classes needed to contain 150 students without reaching 22. So now you just need to think about 150 divided by 21 students, which then you can see that, well, it's going to go to 7 with a remainder of 3, right? It means that now at most, you can have 7 classes, each with 21 students, and you still have 3 students left who must go into one of these classes, making it at least 22. Can there be 8 classes? No, because if I have 8 classes, then 8 times 21 is going to go to 168 students, which means that if you have 8 classes, you can at most contain 168 students without having one of these classes reaching at least 22 students. All right? So now, you can just say that there are 7 classes at most. Is that okay? Just a simple division and you can solve this problem. All right, and for question number 18. So question number 18 is using the principle of if 2 numbers have the same sum, the smaller the difference, the bigger the product. However, you can see that they don't really have the same number of digits in the both of them, right? So it means that when you're just trying to have different combinations there, they won't be of the same sum. However, you want the largest product, so it means that if you're just trying to think about it as a 3-digit number multiplying another 3-digit number with a 0 behind, then the sum will always be the same on each digit, okay? So it means that for the highest places, you have to choose the largest digits, right? And for the lower places, you choose the smaller digits. So first of all, we have 5 and 4 right there. And then we will have wanting to be the smallest difference, 3 and 2. And then we have the 1. Now we are just trying to compare that with if you have 5 in the 2-digit number, 4 in the 3-digit number. Comparing that with 520 and 431, you can just see that for these 2 numbers, adding them up will have the same sum of 951, right? And which one of them has a smaller difference? The smaller difference must appear in this set of numbers, right? So now we would just have 431 multiplying 52 as the answer. So it goes to 5, 21, and that is going to be 1 22,412. Is that okay? Answer for question 15 and 16, okay. This is question number 15. And this is question number 16. Okay. So, for question number 19, if the 101 digit number A is going to be 50 of 8 with a single digit and 50 of 9s, and that's going to be divisible by 7. So how do we find this digit, which is represented by a box? So now what we can see is that, first of all, you need to know that if you have 7 multiplying 11 multiplying 13 is going to be 1001, right? So if 1001 is a multiple of 7, you will also see that 111, 111 is going to be 1001 times 111. Yeah? So now, it means that every 6 consecutive digits being the same digit is going to be divisible by 7. Is that making sense? So now for this number, we can just try to consider splitting it into different sections. First of all, we know that this is going to be 6 consecutive digits, right? So first of all, I can have 8, 8, 8, 48 of 8s, and then you would have 0, 0, 0, 53 of zeros. That is going to be divisible by 7. All right? And we also know that if you have 9, for 48 of 9s, it is also going to be divisible by 7. Right? Which means now what I have left is going to be the middle 5 digits, which is going to be 8, 8, box, 9, 9, with 48 of zeros behind. Does that make sense? So, we know that these 48 of zeros is not going to affect whether this number is divisible by 7, right? Because they are just all multiplying 10s all the way, yeah? So it means that I just need to make sure that 8, 8, box, 9, 9 is divisible by 7. So now, if you're just trying to divide it by 7, we can do a little bit of a number puzzle. 7 divided by 1, 7 times 1, that's 7. So you have 1 and 8 there, right? Dropping the 8. 2 goes to 14. Now you're dropping 14, a 4 and box. Now after that, you have 9 and 9. So it means that you can just try to skip 2 rows until you get the last one, which is 49. And that's going to be 7 times 7, which goes to 49. And if you trace it back, what would leave a 4 when this is going to be a 9? Which means that this has got to be a 5, right? And 7 times 5 is the only way that it's going to end with a 5. So it means that this is going to be 35, and now you would have 39 right there. Because if it is 49, then it's already divisible, right? So it means that 7 times something is going to be having a 3 there as the remaining. So it has to be 42. Because if it is 49, then definitely this is going to be 50 something, right? So it has to be 7 times 6, which is 42. And in the box, we would be having a 5 there. Okay? So we can just solve it like a little bit of a number puzzle, and we can see that the letter, the digit represented by the box is going to be 5. Is that okay? So this is how we can solve this question. And moving on to the next one. It is a little bit of algebra for this complete square question, like a perfect rectangle question. So, we are told that there are 9 squares inside, and the side lengths of A and B are 4 and 7 respectively. Now, if I want to express the other squares, I would want to know the side length of the tiny square right there. Because we don't know it, so let's call it n first. So if the side length of the tiny square is n, it means that I would have this square next to it, 7 adding n. And then for the square below, you would have n adding 7 adding n, which is going to be 7 adding 2n. And for the next one, it is an n extra, so that's 7 adding 3n. Now, if you're just trying to compare this edge between the 2 squares on top and the 2 squares below, we can see that the 2 squares on top is going to have 4 adding 7. The 2 squares below is going to be 7 adding 3n adding n. So now we know 4 adding 7 is 7 adding 4n, right? Which means 4 is equal to 4n, and n is equal to 1. So knowing that, we can then replace the side lengths of these squares all by numbers. So it means that this tiny square is going to be 1. The one next to it is 8. The one next to it is 9. And the one next to it is 10. So this is 14. This is 18, and this is 15. Of course, all of these are side lengths, all right? So it means that the side length right there is going to be 18 adding 14, which is 32. The side length on top or below is going to be 33. So the perimeter is going to be 32 adding 33 in brackets, that's 65, times 2, which is 130, okay? So that's what we have for this question. Are we all good? That's question 20. Now, question 21. Fill in the appropriate numbers in the blanks to make the sum of each row, column, and diagonal equal. So this is a magic square, which is 4 by 4. Now I want to find b times c, take away a times d. There's no direct ways of finding it. We just need to fill in these 4 numbers. And we can already find the sum by taking any one of these rows or columns, all right? Let's say the bottom one. That's going to be easy to find. So you can see that the magic sum is going to be 24 adding 41 adding 0 adding 12. That's going to go to 77. And for these, so A adding B being 46, now we can just take a look at B adding D. In this column, 77 take away 14, that is 63. And finally, we can look at this diagonal. to see that A adding D is going to be equal to 77 take away 52, that is going to 25. So now we also know that A adding 2 times of B, adding D, if you're combining the first two, is going to go to 109, which means that if you're removing A adding D, which is 25, that goes to 2B equals to 84, which means B is 42. So now knowing B is 42, we can then find out A to be 4, right? Because A adding B is 46, and D is going to be 21. And finally, you can just remove 44, 21, and 2 to see that C is going to be 10. Is that right? So now we have B times C, take away A times D, being 42 times 10, take away 4 times 21, which is going to go to 420, take away 84, that is 336. Is that right? So, that's the answer to question number 21, 336. Okay, question number 22. 200 students stand in line facing the teacher. From the left to the right, the students are numbering themselves from 1 to 200. And then the teacher asks the students with numbers that are multiples of 9 to turn around 180 degrees. And next, students with numbers that are multiples of 6, turning around 180 degrees. So the number of students facing the teacher are going to be the students who turns 0 times, adding the students who have turned 2 times, right? Or, in other words, you can also do it as 200 take away those who have turned 1 time only. Is that making sense? So in order for them to turn 1 time only, they have to be multiples of 9 or multiples of 6, but not the multiples of both. So we can do a little bit of a Venn diagram there. So let's say this is the circles. First of all, we know that the lowest common multiple of 9 and 6 is going to be 18, right? So in the overlapping part, these are multiples of 18. When you have 200 divided by 18, you can see that there's going to be 11, which means that there's going to be 11 numbers that are both a multiple of 9 and of 6. The same goes for the multiples of 9. 200 divided by 9, that's going to be 22. So it means that there are 22 multiples of 9, but 11 of them are also multiples of 6. So the other 11 are just multiples of 9. As for the multiple of 6, there are 33 of multiples of 6. And 11 of them are multiples of 9. So the other 22 are not. Which means that altogether, the number of students who have turned only 1 time is going to be the 11 for the multiples of 9 only, and 22 for the multiples of 6 only. So the number of students is going to be 200 take away 33, which is 167 students facing the teacher. Is that okay? So that's for question number 22. And now, as for question 23, this is a distance problem. When Eddie's mom is 1,000 meters away from their home, Eddie and his puppy run towards the direction of Eddie's mom. Eddie's mom walks at a speed of 60 meters per minute. Eddie's speed is 40 meters per minute, and the puppy's speed is 250 meters per minute. So when the puppy meets Eddie's mom, it turns back to Eddie, and when it meets Eddie, it turns back to Eddie's mom, and again and again and again. So now, if the speeds are constant, how long has the puppy traveled when Eddie and his mom meet up? So in this question, if you're thinking about how the puppy is running, then it would be really confusing. However, what we know is that no matter how the puppy is running, the time that the puppy is running is going to be the same as the time that Eddie's mom is walking or the time that Eddie is walking, right? And in the whole journey, 22. So this is for question 22, all right? Okay, so let's get back to this question. And in the whole journey, Eddie and his mom are always walking towards each other, right? Without changing their directions. So we can calculate the total time spent or the traveling time by the distance between them, which is 1,000, divided by the combined speed of Eddie's mom and Eddie together, which is 60 adding 40. So now we have 1,000 divided by 100, which means that the time for the travel is going to be 10 minutes. So in this 10 minutes, the puppy is constantly running at a speed of 250 meters per minute, right? So the distance of puppy is just going to be the time, 10 minutes, multiplying the speed, 250. And that is going to be 2,500 meters. Is that okay? So that's how far the puppy has traveled. (22). So basically 22 is just the total number of students, taking away those who are only a multiple of 9 or only a multiple of 6. So 11 and 22. For the middle part, they are facing the teacher because that's turning 2 times. First for multiple of 9, then for multiple of 6. Okay? So that's how we get it for this one. 200 take away 33. And now, for question number 24, we have 3 adventurers exploring a forest together. They found it boring, so they played cards together. But first of all, in the first game, A lost to B and C, and the winners, the 2 winners, are both doubling their money. In the second game, A and B won, so A and B are doubling their money. In the third game, A and C won, so A and C are doubling their money. And in the end, they all have the same amount of money in their hands now. So, you can just try to walk backwards from this question, all right? First of all, let's start with in the end. We have A, B, and C. Let's say in the end, each of them has got 1 unit of money, all right? So it means that for a previous round, because we know the last round A and C won, right? Their money doubled. So it means that before doubling, they each have a half of a unit, and the extra is going to be. The total money they have is always going to be 3 parts, right? So that's going to be 2 parts for B, 1 round ago. And for 2 rounds ago, we know that A and B won, right? So it means that before winning, B is just having 1 unit. As for A is just having half of that, half of a half, which is a quarter unit. And as for C is having 7 quarters of a unit. Is that right? Because the total is always going to be 3 units, yeah? So just a little bit of calculation. And it means that in the beginning, which is 3 rounds ago, A has lost to B and C, right? So B has doubled, which means before that, B just has 1/2 of a unit. C has doubled, which means that before that, C has only got 7/8 of a unit. And as for A, that's going to be 13/8 of a unit. Is that okay? Now, we know that A has lost $100 from 13/8 to 1. So it means that 5/8 of a unit is $100. An eighth of a unit is $20. So A has 13/8, that's going to be 260. B has 4/8, that's going to be 80. C has 7/8, that's going to be 140. Is that right? So that's how much they have in the beginning. Well, we just have 2 questions left, okay? So this is for question 24. Oh, actually just 1 question left. This is 25, all right? So the last one, we have the numbers A, B, C, D, A, B, C, A, B, and A adding to 1,370. So we want to find A, B, C, D. Now, first of all, we can realize that A is appearing in the thousands place once, the hundreds place once, tens place once, and ones place once, right? Which means that altogether, I have 1,111 times of A. And for the same reason, similar reasons, 111 times of B, 11 times of C, and 1 time of D, which is adding up to 1,370. So now, the thousands place, the 1 must come from the 1,111, because 111 B's has a maximum of 999, right? So it means that A is going to be 1 in this question. And now, if you're removing 1,111, you would then get 111B, adding 11C, adding D is going to be 259. Which then, the highest place is 2, it tells us that B has to be a 2. And 11C, adding D, is going to be 259 take away 222, that's 37. So we also know that C is going to be a 3. And D is going to be 37 take away 33, that is 4. So it means that A, B, C, D is going to be 1, 2, 3, 4. Is that okay? And for the second part of this question, now we have a 4-digit number. Let's call it A, B, C, D. Maybe I should use another color right there, just so that you don't confuse it with the first question. Now, it is added to the sum of its digits, which means that you're adding A, you're adding B, you're adding C, and you're adding D. Yep? So now, that goes to 2014, which means that for A, it is in the thousands place and the ones place, so we have 1001A. For B, we have 101B. For C, we have tens place, ones place, so 11C. For D, we have 1, 1, so 2D. That's going to add up to 2014. Now in this question, it says, what is the sum of all such 4-digit numbers? Which the question is hinting that there's going to be more than one possibility, right? So let's try to think about case 1. Of course, A cannot be 0, so let's think about whether A can be 1. If A is 1, it means that 101B adding 11C adding 2D is going to be 1013, which B has to be a 9, otherwise it would never get to a 4-digit number, right? So when B is 9, you're just taking away 909 from there. So 91 adding 13, that's going to be 104. So 11C adding 2D is 104. Now you can see that this is an even number. This is also an even number, which means 11C has to be an even number. So C can only be 8 in this case. All right, so 11C is 88, 104 take away 88, that's going to be 16. So 2D is 16 and D is going to be 8. So in case 1, we have A, B, C, D equals to 1988. Is that right? And now, let's talk about case 2. In case 2, let's say A is equal to 2. So now we have 101B adding 11C adding 2D. It's going to be 2014 take away 2002, right? So that's going to be 12. B has to be 0. Which means that 11C adding 2D is 12. Since this is going to be even, we know 12 is also even, so 11C has to be even, which C can definitely not go any way beyond 1, right? Otherwise, it will be greater than 12. So it means that C is also going to be 0, and D is going to be 6. So in case 2, we have A, B, C, D equals to 2006. Is that making sense? So altogether, for the sum of these digits, that's going to be 1988 adding 2006, which goes to 3994. And that's going to be the answer for the last question. Is that okay? So that's everything we have for today. Thank you all for coming, and I will see you exactly the same time next week. All right? 7 to 8 next Thursday. Okay, so that's it, everyone. Have a good night, and I will see you all next week. Bye-bye. Thank you.